update our Teach Tracker. So the skills that we did for the recent unit was all of these. So we have actually completed reporting category number 2. So you can highlight that. So we have completed all of reporting category 2 and 3. So we are finished with linear functions, finally. We've been on them for a long time.
So we just color out that one.
Yep. So the next thing we're learning is about exponent rules and then exponential functions. So that is our next unit. So let's go ahead and I think we're kind of running out of room. So we're going to skip a unit divider. Skip a pocket. How about that? And we'll just do the unit divider in this next page. So I'm going to pass out the unit dividers and y'all will put those in. We got bright pink this time. So we are starting unit 8. We do have a few more skills in here that are not listed. They were left off. The skills that we are doing is A, 11A, and B. Oh, y'all cannot see that, can y'all? Is that a little better? A, 11A, and B, exponent rules. That is a really bad glare on it. There we go. Shh. A, 11A, and B, the exponent rules. And then we'll go through all the exponential functions after we do the exponent rules. All right, so let's go to the next page in our journal, and we are going to do a little bit of notes. Multiplication and exponents. So for an exponent, let's say it's a to the b power. A is called the base. B is called the exponent. And what the exponent tells us is how many times A is being multiplied times itself. So if I say 4 to the 3rd power, that means 4 times 4 times 4. You expand it out. So that's the expanded form. We can use the calculator for this, of course, or we can break it down into smaller problems. So like 4 times 4 is 16. And then you do times 4. 16 times 4. Do y'all know what that is? It's 64, actually. Okay, let's do another problem. 3 cubed. So I expanded out 3 times 3 times 3. 3 times 3, 9. 9 times 3, 27. Yep. Okay, what about 4 squared times 4? Yeah, you could solve the 4 squared first. What is that?
62.
Times 4. Haven't we already done that? 64, right. So 4 squared times 4 is actually the same as 4 cubed. Okay, what about 3 times 3 squared? Following our order of operations, right? What would we do first? Yep. So it'd be 9. 3 times 9 is 27. These are the same too. Okay, let's do 2 squared times 2 to the third. What's 2 squared? 4. Do y'all know what 2 to the third is? Yeah, because it's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Four times 8 is 32. So there will be tests in y'all's future, like the TSI, SAT, that you don't have a calculator. So that's why it's important to know how to find it and how to break it down into a smaller problem instead of just plugging it into the calculator. The next one is 2 to the 5th. No, because what does 2 to the 5th mean?
2 times 2 times 2. It's
32. Why do you say that?
4 times 4 times 2.
4 times 4 times 2. So breaking it down, 16 times 2. So these two are the same. 2 squared times 2 to the third and 2 to the 5th. Those are the same. Okay, what about 2 to the 4th times 2 squared? Two times 2. So 4 times. And then 2 times 2. 2 times. Do we know what 2 to the 4th is? 2 times 2 and 2 times 2. So 4 times 4. 16 times 2 times 2. 4. Do we know what 16 times 4 is? 64, right? We've done that before. Or what about this 2 to the 5th? What if we do it one more time? 2 to the 5th times 2. That would also be 64, right? Because 2 to the 5th we know is 32 times 2 is 64. Okay, are y'all finding any patterns here? Whenever you do your exponents, you multiply times itself. What about 45 to the 15th power? 54 to the 15th power times 54 to the third power. No, we're not. We're going to simplify it. We're not going to find the answer. We're going to simplify it. Put it as 54 to the something power. 54 to what power?
18.
Why do you say that?
15 plus 30.
So you have 15 54s. Then you have 3 54s. So you just add your exponents. That's a lot easier, isn't it? So a to the 6 times a to the 8. What would I do with that? Add the 6 and 8. Because this was like listing this out. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. How many total A's are being multiplied times each other? 14. So that is my new exponent, a to the 14th power. So what is the rule when you multiply like bases? What do I do with the exponents? Yep. Add exponents when you multiply like bases. Just like terms, we're talking about like bases. Add exponents when you multiply like bases. So would this made our job a little bit easier? Yeah. Okay, so we are going to look at some examples now. Okay, so I just passed out the foldable. So what we actually need to do is cut this, the bottom, and then turn it the way that mine looks, and then cut the top. And you'll have it look like this. And then fold it over to the dotted line. And cut the tab on the dotted line again. So it's like this. And we are going to do product of powers first. So let's look at the top one. It says product of power. So that's actually the rule that we learned already. For any number A, so your base is A. Don't glue anything. And all integers m and n. So m and n are your exponents. If you have a to the m times a to the n, it equals a to the m plus n. You add exponents. So that's what I'm writing out to set. Add exponents. So let's look what we have. Our first example, it says simplify. A to the third power, B, times, oh, it has a 4 out front. 3, A squared, B to the 5th. So you're looking for like bases, and you're going to put them next door to each other. So I'm going to rewrite this with like bases together. You always want to put the number first, too. So this is going to be 4 times 3 So I've used those. Then we'll do the a's next. A to the third power, b. No, I need to do the other a squared. And then b and b5. Now you multiply your like bases. So we can multiply 4 times 3. 12. And then let's look at the a's. A cubed and a squared. So that means I have a cubed, and so 3 a's and then 2 a's. So how many a's will I have? 5. This one's kind of tricky because we have b and then b5. It'd be 6 because how many b's do I have right here? 1. So if you don't see anything, it automatically means that's a 1. So don't forget that. So it's b6. All right, let's go to the inside. Go ahead and do these two on your own. All right, let's go ahead and do the first one. Y times y5. Y6, yeah, because there's nothing there. We got to put a 1, so y6. M squared times M7. M9. All right, the next one, we have a mix of 2 different variables. So we're going to have to put our like terms beside each other. So how many r's? Yeah, so we have r times r, which we know that that's going to be r squared, but let's not do it yet. It's okay if you did. And then we have n to the third and n squared. So r times r squared. And then n times n cubed times n squared. Yeah, 3 plus 1 is 4, plus 2 more is 6. Yeah. Okay, the next one, go ahead and put your like terms beside each other. Let's do the numbers out front. So what numbers? So -4 times a -5. X cubed, x7. X10. All right, let's do the next one. -3j squared, k4, 2jk6. Put your like terms beside each other. -3 times 2, j squared, j, k4, k6. -3 times 2, j2 times j, k4, k6, k10. That's right. All right, good job. All right, go back to your journal, and we're going to write something on the next page right here. Okay, this one is raising terms with exponents to a power. Raising terms with exponents to a power. All right, the first one is going to be 3 times 3 squared. What do we do there? Yep. 3 times 3 is 9. Squared is 81. Okay, the next one is going to be 2 to the third squared. No, because it's not beside each other. Because what does the squared mean? That means that you're doing 2 to the third times 2 to the third, right? So you could look at it like this, because squared means it times itself, with it being 2 to the third. 2 to the third times itself. Or you could look at it as 2 to the third is 8. All right, because 2 times 2 is 4. 4 times 2 is 8. 8 squared is 64. But if we look at it this way, what would this end up coming out to be? No? 2. 2 to the 6. Which, what's 2 cubed? 8. 8 times 8 is 64. So this is the same as that. So look at it. 2 cubed squared is the same thing as 2 to the 6th power. So we didn't add the 3 and the 2. What did we do with the 3 and the 2 when they're separated by parentheses? With what operation? How did we get 2 to the third squared to become 2 to the 6th? What would you do with the 3 and the 2 of exponents beside each other?
You just
Multiply them. Yep. All right, so let's look at a squared to the 6th power. What does that mean? A squared, how many times? Yeah. So 6 times. But what do we end up doing with those exponents now? Add them 2 plus 2 plus 2 plus 2 plus 2 plus 2. A to the 12. Do you see what we did here? What do you do with those exponents? Multiply. What am I multiplying? 2 times 6. Okay, let's do another one. 4 squared to the 3rd power. Four squared to the 3rd power? That means you're going to multiply 4 squared times itself 3 times. 4 squared, 4 squared, 4 squared. There's 3 of them. Yeah, it's 16 times 16 times 16. Let's keep them as a base and exponent, though. What will it end up being? 4 to the 6th power, right? Okay, what about 4 to the 3rd raised to the a power? That's weird, right? What is this going to mean for us? A, we don't know what A is. A could be anything. No? It could be a 10, it could be a 20, it could be anything. But what this means is you're multiplying 4 1/3 times itself how many times? Remember I said 3 times here, 6 times here. How many times? A times. What do we do with the 3 and the A to simplify that? Multiply them, because what do we do with the 2 and the 3? Multiply. What do we do with the 2 and the 6? To get the 12 here. The 2 and the 6 were multiplied together to get the A12. The 2 and the 3 were multiplied together to get the 6. Remember how multiplication is just repeated addition? Y'all learned that back in like 3rd grade? Instead of saying 5 plus 5 plus 5 plus 5 plus 5, what do we do? 5 times however many there are. This is the same concept. So you would multiply, because we're not sure how many is A times, so we just multiply 3 times A. So it's 4 to the 3A. That's simplified. Somebody's phone. 3A squared to the 3rd. So let's expand this out. What is this going to be? So how many times is 3 being multiplied times itself? 3 times. So this will be 3 to the 3rd. And then how many times, how many A's will you have now? A squared, A squared, A squared. A6, yeah. Which we could simplify that. What's 3 times 3? 9 times 3 more. So it's 27A6. All right, so we need to write a rule for this one because we wrote a rule for the last one. So what do we do with our exponents when they're separated by parentheses? Multiply them. So this is called when raising an exponent to a power, multiply the exponents. This is called power of a power. Exponents are like powers, to the 3rd power, to the 5th power. When raising an exponent to a power, multiply your exponents. So the way that I remember is that if there's a separation, you only have one. You have bases inside the parentheses and an exponent outside the parentheses. You multiply your exponents. So let's look at the examples we have on our foldable. Power to a power. For any number A and all integers m and n, you're going to do A to the m, n would be m times n is your exponent. So if we look at this one, b to the 5th to the 3rd power, what's that going to be? So it'll be b to the what? 15. You would multiply those exponents. All right, so let's look at the inside ones. Y to the 5th squared. See how they're separated by a parentheses? How many y's would we have? 10. So do y'all see the difference between these type of problems? Each exponent has a base. This one, you have parentheses, and you have an extra exponent. All right, the next one. We're going to have to simplify separately. We need to simplify this first. X10, and then we got to bring down the X3. What do I do with X10 and X3, though? Add them, yes. X13. All right, so we're going to stop there, and you have a Delta Math assignment. Show your work on a sheet of paper, and you will turn it in.